Okay, so welcome back. We're going to continue on. We have the binomial distribution function. So I was using this function when I solved the problem in the last time. I just want to point out this NCX is obviously n choose r. When I was saying things like 4 choose 1, and I was writing it in a different notation where I wrote, for instance, 4 over, I'm sorry, I didn't write 4 over, I didn't do it like a fraction, but I wrote 4 and then a 1 and I put parentheses around it. That is the notation I was using for that same thing for this thing. P to the x, obviously, if we want the probability of success times the probability of failure, and we just increased it by 1 each time here, we decreased it by 1 each time here, and we multiplied all that together to get each individual part from 0 to n. So one thing, before you use it, be sure to before you use a binomial probability distribution function, be sure that it fits the binomial form, because if it doesn't, that's going to look bad, or that's going to be bad. You're going to do a lot of work, and by doing that, you're going to do a lot of work, and it's going to be for nothing, because obviously we can't technically use it if you don't. All right, so binomial using technology. So you can use your calculator to do this. Some notes for you are pushing second vars will bring up the distribution list. This is for your TI-83, TI-84. Two options, binom PDF and binom CDF, given that x is equal to 0, 1, 2, or 3. PDF will give you a specific instance for if x is equal to 1. So if you want to know when x is equal to 1, so like for instance with the last problem that we did, we wanted p of 0. If you wanted to know p of 0, you could use PDF, and that will tell you specifically at 0 what happens. With that being said, CDF is considered to be cumulative, and so if we use CDF, we are going to get every value equal to or less than the value that is stated. So for instance, if you do the CDF of x equal to 1, it's going to calculate p of 0 plus p of 1 and give you that value. Okay, and so there are 4 different possibilities for CDF: less than or equal to, greater than, and greater than or equal to. Binom CDF by default does less than or equal to, and that's important because it changes your formula a little bit each time. If a problem indicates no more than or less than or equal to, then you're using that. And so simply using the binom CDF, where you put n, the probability of p being successful, and x, number of successes, where n is the number of trials, p is the probability of success, and x is the most number of successes. And so let's say that you have 4 trials, you have a probability that's 30%, and you want to know 2 of them. If you put binom CDF 4.30, and we said 2 successes, so 2, then it will calculate probability of 0 plus probability of 1 plus probability of 2, and it will spit out a number, and that number will be the probability of all of those combined. Okay. If a problem indicates less than, then our binom CDF changes a little. We're going to use binom CDF, but when you go to put x in, you need to do x minus 1 here. And so what that means is in your head, you have to remember if it's less than, if you want less than 2, for instance, then you need to put binom CDF, n is 4, p is 0.30, and instead of putting 2, you're going to do 2 minus 1, which is 1, because the calculator will not know that you are trying to do less than. It will always do less than or equal to. And so if you just adjust your number of successes manually in your head, then you can keep it that way, or you can keep track of everything, and you can take care of everything. Since the calculator only knows, obviously, since it only knows less than or equal to, this will correct the fact that we do not want to include x itself in the calculation. Okay, so once again, just to reiterate, if x is equal to 2, but you want less than 2, you need to put 1 into the calculator just to adjust it so that it doesn't include 2 and subtract too much of the information. If a problem indicates greater than, since our calculator only does less than or equal to, we have to use the complement. So you're going to do 1 minus binom CDF NPX. And so you'll just do 1 minus and then put the information in as it follows. and you should get out the value that you hoped to get out of it. Okay, and then if a problem indicates greater than or equal to, no less than, or if the problem indicates greater than or equal to, or no less than, which is greater than or equal to, since our calculator does less than or equal to, we will use 1 minus binom CDF, and we'll also adjust x accordingly because we don't want to include the number that was given to us. It's always 1 minus that. And so just to reiterate, here are the 4 formulas. You've got binom CDF, and I've given you each individual one. Less than or equal to, greater than, less than or equal to, less than, greater than or equal to. PDF does not require any modifications ever, though. So if you're using a PDF, you don't need to modify. All right, so we have another example problem, so I'm going to stop the video and I'll give you I'll start up on a new one here in a second. Thanks for watching.